make it as smooth as possible so when it's going into his throat, it's
Look, I had a endoscopy about 2 months ago.
okay, yeah.
I am familiar.
You know,
yes.
yeah, you know.
Yes, I do.
So yeah, that's and another thing is they're doing one. You see, there's 4 of these electrodes around here. They're doing one at a time.
Right.
They're doing one at a time in production. They wanted us to try to speed it up as much as they could. So we're trying to, and we've done it successfully, is doing 2 at a time. Do half, do the 2 long ones, and then rotate it and do the 2 short ones. And because of that, we had to redesign the little applicator tip. The one they're using up there is smaller, just to cover 1. We redesigned it so it'll do 2 at a time. So we went through a couple of iterations of that, and then you can see we ended up with one that works pretty good.
This is nice. I mean, this is really interesting. I just wish that at one time we had our middle school kids come through, high school kids come through to be able to see the Innovation Day and all the different things. But because the time changed, right? Because we had it early, like 11. I think we had 11 to like 4, where the kids could come in. But it's later now. So. Well, good deal.
Thank you.
Good job.
Thank you very much.
Good job. How do you guys? Congratulations.
Good day. Any questions on this? You want a little rundown?
That's my son.
Oh, yeah?
I'm supposed to see his project.
Okay, yeah.
I braved all the weather and everything.
Yeah.
Can you explain it to me a little bit?
Yeah, so we're Medtronic, and you got the tubes, and like you were saying, is it's going to be air.
Okay, first tell me, what is your project about?
So that's where we're making this fixture, and we have to work with these tubes, and what we're going to be doing is these are silver ink to read nerves in here, but they don't want it reading all the way up here. They just want it conductive down here. So we have to insulate all of this, right?
Is this for medical?
Medical stuff for surgery. Going down your throat. Yeah, sorry. We paint on that to insulate it, and we're using this. It's a UV curing adhesive, but we're just using it as basically paint. So that's it applies. You can see the big black canister back there. That's pressurized with air, and then it'll apply it right with the little red valve there. We'll apply it along the tube, paint on, and it'll come up, over, apply it behind the little shield. The lights kick on, and it cures it, and then it comes back up, over, and then the tube rotates 180 degrees. It comes back and does another pass.
So what is it going to be used for?
This is for prototyping. They're already in production. They're already making these, but they wanted a smaller fixture so they don't have to shut down production in order to get a few tubes.
I see, but the tubing is what it's going to be used for.
Oh, it's during surgery.
So for opening
up down in here. I'm not exactly sure if I think it's thyroid is one of them, and they're actually working with the nerve itself.
I see. So can you put an instrument through it?
Well, that's the thing is this is the instrument. It's a sensing. You have the harness which connects up here, and then they'll run a small electrical pulse through it, and then when you're getting close to that nerve, it actually it'll change the signal, and they'll say, okay, we got to stop cutting, and we're going to cut the nerve.
Oh, I see. Okay, so you can cut using you can cut.
This is just a sensor. This is not.
Sensor, right?
Yeah, so when they're actually going in, they're cutting, it'll change. They're getting closer.
Okay, got it.
We're getting close.
So again, tell me a little bit about what you were talking about earlier.
Yeah, so this is, they only want it conducted down here because they're going to place this right next to the nerve where they're doing surgery. And then so all of this will be covered. And then I don't know where it ended up. We had one with the little clamshell where the harness attaches here, little plastic piece that snaps around here. But all of this from really that right there all the way up will be covered by this Loctite to insulate it, so it's only conductive down here. Just right, they can place it right. They don't have any other spurious signals from up here or anywhere else.
My sister worked at
Yeah.
and another relative worked there.
That's my dad works there.
Oh, really? So I guess you do a lot in medical,
Just carry it over. I mean, hey, it's a smart idea. You get more memory that way, more storage on there in case you're handling big
Oh, I must run the picture.
I told everybody, all the groups, the same thing. It's not a specific.
Just bring our own power supply.
Yeah. One of the little suitcases.
Yeah.
Sit in the corner.
Got a hand crank. Crank it up.
So I think some groups have like water, and have like
Yeah, we want
water, like that. So it's plenty.
Just in case if the polycarbonate doesn't work, nobody's gonna get hurt. The emblem, it's actually for the brand itself. It's a pirate emblem. Oh yeah, like I left it in there, like I was throwing it out, but actually I left it in. Yeah, actually, just got the suit for this day. Yeah. Thank you, I appreciate it. I'm trying to impress everyone. Come here to do that.
What are you guys doing after?
So I'm actually going to go to UNF. I was originally going to go. I was talking to Bessiati, but I found out that someone's got dynamic control systems that are offering that. So we can go there for the aerospace program. Yeah. They actually have on UCF, they have like a bunch of lots for like different companies that are hiring engineers there. Like the one of the ones I'm thinking of right now is not saying because I already have an internship with one of their sub-branch companies. They have like a whole plot of land sitting there at UCF for all engineers who like yeah, so that's what I'm thinking. Yeah, that's why I tried to. I got some. I'm trying to get some experience this summer. I still have some time before the fall semester starts. I start my master's, so I'm working in Virginia for a little bit. Work on the carriers that they have there, and then come back and start working on my master's. Yeah, I want to get it done. That's all I'm working on. Yeah, I've been working part-time for 4.5 years now, so it's not full-time. A little bit of a change for you. Yes, but full-time. So it was Innovative Manufacturing Solutions. We do medical device stuff for Zimmer, some biomed, got bought out, and then now we're D-Tech Mechatronic Solutions. We're working with a company called Plasmatic, which does big water and other fluid control systems, valves, mainly. And then D-Tech is going to focus on pump production and then also the actual actuators. So I'm going to be toolmaker, machinist.
Oh, yeah, you made it already.
We just started
Leading from that, our job is to cover it, so we put it in the main room. At first position it like this, and then come down over this, and then turn 180 degrees over this part. Video out. No, this is EMC. Sorry. You want to know about we work with it. Okay. We work with Medtronic want us to do they gave a lead trip, and what we need to do is to cover this. So this electrode, this part of the electrode don't contact to the patient body. Like, similar to this, we need to cover it. With this trip, we will put into the patient throat when they undergo the surgery, so that the patient can breathe through this tip. Yeah, and what they want to cover this part, just leave the electrode open so it contact to the nerve, patient nerve, so that they can monitor if the nerve is intact or not. Don't be cut accidentally. And if the surgeon have the blade very close to the nerve, it will another machine will generate a warning sign for children not cut the nerve. So what our job is to cover this, yeah. And what we come up with is this picture. We will put it, we open it. Đây là không xong rồi. Trên này this we will put in here.
Oh, I see. I see.
Yeah, you see that?
I see. Cool.
So we take it out, put this into the main room like this position, and at first position this is on the top. This will be on the top. So this is we call it pure soft valve. It had two airline here, one airline to turn on turn off the lock tie feature.
I see.
Then we go down, contact the gate, and lock tie will come out.
I see.
And then
Unfortunately, it looks like the clamshell fell off.
that motor controls the whole thing goes to the right side. Stop here, and then go up, go here, and go down here. To high after this too, and that time the UV light will turn on to serve the lock
Connected to
tie.
right here.
And then this motor will control the tip.
Oh, I see. So you can rotate it.
Yeah. And then it go up, go to this side, and go down here.
So you're only breathing.
And apply the lock tie, then go up, go here, go down, and then UV light will turn on.
Oh, I see.
And this will go to this position so the operator will easy to take it down. And put it on. You can see the
I'll watch this. Thank you.
You see that UV light right here, it turn on. It turn on in 4 seconds, and to dry the lock tie.
Oh, yes, we're jumping in. So this is, they already have, this is in production, they're making these in production. All this is just a little R&D thing. They don't
You guys are using the exact same steppers that we use sometimes. Those are the STM controllers.
The lock tie will be in here. This is pressurized canister. And when the air turn on, it will fit the lock tie to that and it come down. So the tip.
Yeah, he's the guy to talk to. Hey Blake, what's up? Yeah, we're both sorry.
But they can't do that right now.
Might be gonna tag me. Yeah.
Not safety.
Our group has 5 students, 3 mechanical engineering students, and Philip, electrical engineering student.
Are you electrical?
Let's see this go.
Mechanical engineering student work on the fixture and the axis and attack the motor and attack the screw shot one and make it UV light attack to the fixture. Our work is to make the control box to control and program it to control the motor, UV light, and the relay to turn on, turn off, the air to feed the lock tie.
So do they have to repeat you for their project, or is it just coordinated throughout the university? The other ones, the mechanical, have to come as a consultant to the project.
We contact to one engineer in electronics. He like sponsor for us, and he appointed contact to make mechanics on us. And when we need material, need motor, need aluminum like this, he will order for us.
Electronic supplied the.
On behalf of the School of Engineering and CCEC, I'd like to say thank you to all the guests and visitors for joining us tonight. I would first like to start with saying congratulations to all the seniors graduating and who have worked so hard this year. So for those of you who don't know me, I am Steve Stegon. I'm just part of the teaching team. I do mechanical engineering and advanced manufacturing. Next year will be the first year that we have advanced manufacturing. So civil, mechanical, electrical, and advanced manufacturing, we're continuing to grow. This year, I just wanted to take a couple minutes to recognize the teams that the teachers thought did a great job. First of all, everybody did a great job. So the first project we'd like to recognize is from Civil Engineering, and it's the Senior Capstone Project of the Year for Civil, and it's awarded to Hendricks Road and Amelia Concourse Connection. There's a new program called Artificial Intelligence. I heard of it once. You can put them in the picture. All right, now getting to the mechanical and electrical. The Interdisciplinary Engineering Senior Design Project of the Year goes to a team that really impressed me. And I might be a little biased. I work with research on someone on the team, but I didn't decide this award. Dr. Bevel and Dr. Saras did it. The team this year is South Battery. This team built an entire industrial automation machine over the last 3 months. And it was very impressive, so very well done. The next award goes to the best electrical engineering project. This project was super interesting, and I think the team also did a really great job. The topic is really cool. It goes to Apellis and their work on battery management for Trump. Very well done. Congratulations. awarded to the fuel cell golf cart sponsored by Dr. to take and integrate an industrial fuel cell with essentially a strapped golf cart and have it be safe and functional. So very impressive. I believe it's actually outside, unless Dr. Fletcher is driving it around right now for fun. And just for clarity, there are mechanical and electrical students on this project. They all work together, and this was the best project from a mechanical stance. That definitely needed the electricals as well. So, on behalf of all the graduating seniors, thank you for sponsors. Without you, this would be impossible. Thank you for family members of our students who have supported them through the years. Without that support, they could not have the energy to complete this process. So congratulations, enjoy and savor graduation, get out there and contribute to the job market.
We went together.
Hello. Hi, Casey. Hi.
In case you're wondering who they are, I'm Tad.
Nice to meet you.
Yeah, we hear all about you.
Tommy. Okay, nice to meet you.
He's mad. Did I tell you about the guy who did the pocket square?
No, I didn't.
There was some guy who came by, he was like, he undid the pocket square, and he's like, you should do it right, and then he messed it up. And he was the one who did this one. So now he's back. There you go, buddy. Actually, point the guy out so I can do that. Yeah. There we go, it's perfect again.
Hey, I wanted to take a picture.
You see the picture of the fixture? Sorry. Nice to meet you. Love Philly.
Nice to meet you.
Love Philly. Appreciate it.
In reality, would be one of the best projects.
Did it work? Yeah.
It works. We even did testing.
Yeah. This was our big part. This is where we show. It's beautiful. All right. So basically, I'll explain the whole thing. I've been giving introductions all night. So basically, we got these tubes right here, right? Yeah. Which is now wrapped around.
Wait, let me take a video of you.
All right. Wait. Tube is wrapped.
Tell me when I can start it.
Yeah.
Philip, you have many audience here. So
Okay.
It's exciting.
For everyone. All right. So basically, I'll explain. We have the EMG tube. This is what we were working with Medtronic's MIA Trivantage tube. The tube itself is really used during the throat surgery. What happens is they put the tube down your throat during surgery. This pump right here, they fill it up with air and makes it airtight. So basically, you're only breathing through the tube itself. It's controlled, everything's fine. We then have the electrode right here, which basically what they do is they put this on your nerve, your laryngeal. And so the electricity from your laryngeal will go from here to here, and here's the harness. We got the harness right here. Basically, you put this harness right here onto this part, and this will connect to a computer. And so basically, they can measure your
cut the laryngeal nerve valves. That's what will happen. Also, what they do to make it smoother is that they cover it with Loctite.
You want it?
What's this?
Micro.
All right. So basically, Loctite is an adhesive. They apply it onto here, and then they use these UV lights to cure it, which makes it like a hard, smooth, flexible plastic. And so it makes it like smoother during surgery.
Prevents your slime from not interacting with the silver electrodes.
Yeah, that's the other thing too. The problem is that the Loctite that they're using is a little too hard, and they want to find better Loctites. The only thing is they use an industrial line, and so it's like to test these different types of Loctite, you can't use the industrial line. You need your R&D engineers to be able to do it, and so that's where we have our fixture that comes into play. It's a fixture that's able to apply different materials, different Loctites, different like PVC clamshells to hold the harness into place. We use the fixture right here to do that. The R&D engineers are able to use it. For the fixture itself, what you take the tube, you take one of these tubes, and you put it in the mandrel itself. And so it's like you place it here. You then, we can go over to this video. You then start the run cycle. Before I start, actually, what happens right here, the valve has a connection to this hardening canister, which has Loctite inside of it, and then it also has the air pump connection, which pressurizes the system and allows the Loctite to go out. So it's like you press the run cycle, it then starts, and what you're going to see is this tip right here is going to go down, start coating it with Loctite. It will move the tip behind a shield to protect it. It goes down. The lights will turn on. It'll cure the Loctite, protect the tip, and now you got to do the other side. And so the mandrel right here is going to turn around. It's going to go back, go down, apply more Loctite, cure it, and then it's done and it's ready to go. Does the same thing, goes behind the shield, UV light turns on. And that's how it works. And so to test it and to actually see if we got enough Loctite on there, we had to do two different types of testing. We had to do a thickness testing to see if it applied the right amount of thickness to the tube itself. And then we also had to see, was the surface itself actually smooth? And so for the thickness testing, we used this Keonce right here. We took the tube, chopped it up into small pieces, and we did this for multiple tubes. And we took the small sections, and we put it underneath the Keonce, magnified it, and saw, as you can see right here, the PVC, and we saw how thick we made it. For the original tubes, that Medtronic design, it was around 0.2 millimeters. And then for our 2 millimeters to 0.4 millimeters. So it still needs to be worked out a little bit, but we did get around that area that it needs to be. Was it non-count? Used apply the Loctite. This is the one that we made. It was made out of urethane, which is a material that's not necessarily silicone, so it doesn't work as well. And it kind of just scraped off the Loctite. Applied the right amount of Loctite to it.
Between that blue tip and this tip was that blue tip only covers one electrode, while the new tip is supposed to covers half of the entire tube.
Yeah.
So it's more like efficient process.
Yeah. So we're able to get the right. Just once, rather than 4 times, which is what it usually did. And then for the surface roughness test, the Keonce itself, it basically has this feature. So when you take a picture, it makes a 3D analysis of the surface itself. You can see how rough it is. And we basically got these like small bumps that were like 0.01, 0.001 millimeters, negligible. We found out that the surface is actually pretty smooth. For the clamshell itself, which I don't have, this clamshell right here, that's what keeps the harness
onto the tube. It keeps the harness connected to it. We needed to make a new clamshell, and so for that, which is right here, a lot less hard, and it also can handle the UV light because yeah. Put it right there, acknowledgements. Just as worked just as well as the clamshell, and then even better because yeah, it works really well. Yeah.
So I'm assuming you guys got an A on this, right?
We'll see. They still have the report.
They still have to look over the entire
180 pages. I bet you they won't even read it.
portions we need to.
Yeah. I hope so.
Is 9 months worth of work? I didn't read much.
Yeah, I know.
I want to take your picture because you think you look fat right there? It's because you have your jacket and buttons.
I don't think so.
You like it?
I thought it looked pretty good.
Good job.
How come you have your jacket here, the lab view specialist?
Because this is the way you're supposed to do it. I thought it looked nice.
I don't like.
If you have it the other way, you're supposed to put the clip on it. That's what I was told.
What is this?
I think you spent literally 3 months.
You want this back?
Just put here.
Just
Save it for the future. You can show it for your kid.
And it wasn't recording. So it's another perfect beautiful explanation.
It's like a speaker. Sorry, I chimed in.
You got the day.
You can't hear it. I'm like, yes, exactly what you said on it.
Give Frank a hard time.
That's nice.
But I'm not going to stick inside. I have to make it stick.
Like, what even here?
All the pilot. We're doing 40 too. Alrighty. We got a presentation. Alright, So, you got these tubes, you got in your throat, EMG tubes, you got in your throat during surgery. And well, these are a little different, obviously we have air through them. But these have electrodes on them, which is just silver ink that's painted on and then baked, cured. But it's conductive the whole way. Well, they only want it conductive down by the nerve that they're actually near. This is where they're going to do the surgery. They don't want it conductive all along here. So the way they insulate it is they paint on some Loctite. It's a UV curing. It's the same brand as the thread locker, but it's just a UV curing version. And it's actually painted on up here and then is UV cured, and that just insulates the electrode. And the silicone tip here, I think you made the mold for it. Yeah. So, gazillion years ago. Well, small R&D fixture so that they don't have to shut down production in order to go make 50 of them for testing. There's just something for the lab where they can make. So again, all we have to do is paint on that Loctite, and that's what we got. See that? That's a little feeds in the line to actually actuate it, and then it comes down, paints, goes up, goes over, goes behind the little shield, and then the UV lights kick on to cure it, and then it rotates 180 degrees, and it comes up, comes over, comes down, paints the other half, and then goes up, goes over, goes behind the shield, the lights kick on, and then it comes up and over to home so you can get to it, and you pull the tube off and it's done.
This is the UV light?
Yeah, these are the two UV lights. actually put a whole bottle of Loctite and they pressurize the entire thing just to pump through. We were going to have a different. You can see on this one up here. This was the original. It was going to have a syringe. They ended up. Those were back ordered forever, so they just gave us the actual full production version. Yes, the fixture was the main priority, but they are prototyping. So fixtures in production, they're only doing one at a time. Times 4, and then it would cure right there, and then right behind it is the UV light. So just one at a time. So we're attempting and have done is do 2. So there's 4, we do half and then half. Because we're doing 2, we don't have to be as precise in tracking 0 correction as it's going down. But because we're doing half and half, it shouldn't matter. We don't have a vision system. It's just a home position and then rotate 180 degrees. So we did some different testing with the and cast them there. And then
so did you print these?
Yes, those are resin. This one was actually an FDM mold that I made, and then these resin printer on campus we used.
Okay.
So you got we did down here. Here's the section view. Here's the base on top, and then they wanted a consistent thickness throughout, and then they wanted a constant surface roughness to try to match this tube and to be smooth. So that's what we had a little bit issue with in terms of consistency. A stutter. This thing is pretty front heavy, and the rails on the front, it helped a little bit, but it works. It's not perfect. And then the harness and the tube itself, you can see the little pads where the wires will go in. All the clamshell is just a little injection molded snap ring that snaps around and puts some pressure down to hold these down so you have a good electrical connection. And it's wide, 50 ohms. It's huge. They just want to make sure it's connected. Snapped over. They wanted to try to make it smaller. They've actually tried making some translucent ones, and why that's an issue is because we have a UV curing adhesive. If it's opaque, there's no UV light getting underneath. It's going to have uncured Loctite underneath. And if it's fully encapsulated, that wouldn't be a big deal. If it wasn't, and it gets so patient, that's not going to be good. It's an irritant. But then the real concern is the solvent in the Loctite keeps it liquid. Will actually start attacking this silver ink, and over time, if there's uncured Loctite under it, you'll lose the electrical connection over time. So they wanted. And it worked pretty good. Now it's just a matter of get it to a production setting, so we're not having to sit there and.
Right.
But that was. If you finish the project and have some extra time, kind of things, work on this. So that's we were able to do that a little bit. But yeah, that's. And if you want to.
Can I get a picture of you?
Oh sure, yeah.
Yeah.
Yeah. You gonna hold the thing or just?
We might have did a few things in the shop over there. The machine some of these now. Wow.
I'm proud of you, boy.
Thank you.
Yeah. It's like for us, if he was there, it was barely having stuff. But he was an older Italian guy. I remember that. Okay. He always used to joke when I was young. Yeah, that kid's going to be my boss one day, and ultimately I ended up being his boss one day. I tell people about that with him.
We ended up. shortening this. We actually got this from Medtronic.
Yeah.
And short and modify that just to make it just a spacer is all that is. And then the that's the little tailstock too. We were, but this is to walk it down, right? We to walk the mandrel, but we didn't have that mandrel. It was, I mean, you can see it dripping. Right. So now, walk it in, and it's about a. Yeah, but I can.
Yeah. And so anytime we need more Loctite,
Sneak on in here.
the Loctite canisters pressurize.
You can see just a little, just a little bit, and then it's. Yeah, you can go around all about that.
This is
So who did all the electrical?
That would be Tan.
Okay.
Yeah.
That's kind of his.
That's his baby. Him, that, and the programming.
Okay.
And then, this was pretty much mine, with the exception. There was a guy named Alvin. He's not here.
Okay.
He couldn't make it. Yeah, sure.
yeah. So it's like you just put like a.
But
So this will be donated to Medtronic.
But yeah, we're gonna bring it over. Clint came by earlier. He's actually saying there's like 2 engineers waiting to use it. They want to make some prototypes.
Oh, cool.
So
That's real cool.
When they get it over there and start doing it, you should go there and get your picture taken.
yeah, well, that's I'm good chance. We were going to try to run it not with like Loctite or the UV lights, just run the servos.
Yeah.
Oh, you can't put, we're kind of pushing it, plugging in the computer, and they had some concern we were going to pop a breaker with everybody doing it.
Oh, I got
So they made a blanket rule saying nobody can run it. Video of it.
There's safety.
Send these pictures up to Tim, the owner, the guy that I call the company. He's when he came down last August, I guess. Of course, that's exactly when Linda and I had to get COVID.
Yeah.
So it's like
Here we go.
him and
Giving you the honors.
Giving me the honor, so boy. We'll see what happens.
what's that?
It's so that anytime I talk, it connects there, and so they can get a video, hear me clearly.
I see.
Yeah.
Interesting.
But yeah, that's basically how it works.
Yeah, very interesting project.
Yeah. Thank you, I appreciate it. You're with Inspired Energy? Yes.
We had sponsored the riders.
You're out of here? All right, I'll see you guys later.
That's us later, okay?
Yeah. Sorry about that.
We had sponsored the project.
Gotcha. Okay. Oh, wait, are you actually working with a project, or are you like here with the company?
Here with the company.
Okay, gotcha.
Yeah. No, we sells project over there.
Oh, yeah, with Lucas?
Yes.
Yeah. Pretty well. Yeah. They were working on the, was it the way to make the batteries, or was it the...
First step in manufacturing.
Okay, gotcha. Yeah.
Get them ready to go through our process.
Yeah. It seemed like a very interesting project. I liked it a lot, yeah.
How it turned out.
Yeah. That's good.
Good deal. I appreciate walking me through it. Good
Of
job.
course, no problem. How's it going, sir?
Yeah. What was your name?
Philip. What's your name? Tom? That's Tommy. Should know that.
I did your base plate, all your brackets, all your little blocks.
I appreciate that. I remember Tommy telling me you could get it.
Yeah.
Helped out a lot. If anything, we should have put your name in the acknowledgments. I'm sorry we didn't. You deserve to be there. You like working at Medtronic? How long have you been working there?
32 years.
32 years. Okay.
Yeah, a long time.
That is a very long time.
Yeah.
Hi, how's it going? My name is Ari.
Yeah, I'm Tom.
Tom, like Tommy.
I was like, he said Tom, and I was like, wait.
It's like,
I was the
actually.
one who made all your blocks and all your base plate and all that.
That's right.
I said we should have put his name on the acknowledgements.
That was super helpful.
Yeah.
I'm sorry, Tommy didn't put your name there. I'm really sorry.
We should add his name.
Yeah, that's what I'm saying. You know, the same name.
He was raised under one of the best.
Yeah, I appreciate you doing that, though.
No big deal. Good that my boss let me do it.
Yeah.
He's pretty good about stuff like that.
Yeah.
Did you guys, have you looked at all the other projects yet?
What's that?
Have you looked at any of the other projects yet?
Very little.
Obviously, because this is the most important one.
It's the best one. It's the best one. It's the most. They say that the hydrogen fuel cell project was the best. No, it was us. Just can't help it.
They can't. So, I actually just found out today that before Medtronic was here, there was another company here. Did you work for that company originally? I can't remember what its name was called. It was like some other healthcare like production.
Yeah, it was Zomed.
Yeah, them.
Yeah, I worked for Zomed, and they traded hands, and that was Zomed Treese. They merged with Treese Medical, and then about 15 years ago, Medtronic bought us out.
Yeah. Okay.
Yeah, I've been here. I've been there through the whole deal.
Yeah.
I even got let go. I worked like 5 years, and they laid me off.
Oh, really?
And I was working in the R&D in the model shop.
Yeah.
And I got let go from there. The tool room, tool and die shop. They needed somebody.
Yeah.
So it worked out great because I had like a couple months off, and I came back with like $1 an hour raise.
Oh, okay, gotcha. So Medtronic hired you back.
Yeah, and I was able to keep all my seniority and everything.
Okay, that's actually really nice.
It worked out good. If I'd only known I was going to come back, I'd had a nice 2-month vacation.
Yeah.
I'm worried about finding a job and all that good
stuff. That's what they should have said in advance, you know. They're like, hey, you're going to lay out for a little bit, enjoy your vacation.
Yeah, for real.
Yeah.
I had several people pulling for me. The head guy in R&D really liked me.
Yeah.
And then the guy that was running the tool and die shop I was friends with.
Because I'm guessing they had a lot of other people from the company go over to there, right, to Medtronic, yeah. Just because they know it the best, right?
Yeah.
Yeah.
How about how Medtronic employment there? It's like that they hiring freeze now.
Yeah, they have hiring freeze right now.
They just recruit internship. They don't recruit engineers.
I'm not sure. They just let like a dozen people go this last couple of weeks.
Engineers.
Just all across the board, really. Well, I don't think too many engineers. More so manufacturers, some of the lead manufacturing people, the guy that works in sterilization, sterilizer. Really what it is, in company-wide, they're doing quite a bit of layoffs and whatnot. But our division, when the company-wide does that, that's kind of their excuse to, we really need to get rid of this guy. This guy's not productive at all. That's the way of them saying, oh, well, we're company-wide, we're downsizing.
Yeah.
And they can get people out of there without having lawsuits or anything like that.
Yeah, I got it.
That's kind of how it works.
I see. Be right back. Oh, there, guys? Wondering how this works?
We were talking to somebody else about it earlier, but I'm just looking around.
Okay, gotcha. If you want an explanation about it, just let me know.
All right.
What are your thoughts so far?
Looking at it. Let me see here.
What's the tape for?
So the tape was for the tube itself. You have a clamshell holding the harness. So you can see right here, it's holding the harness onto the tube. The clamshell itself is really hard, and so they wanted to make a new design that's softer for when it goes down the patient's throat. And so we made a new design. It was actually a lot better because it can withstand the heat, like the clamshell can. But the other thing is when the Loctite is applied underneath, Loctite acts as a solvent and stops the conductivity between the harness and the ink electrode. The good thing about this, though, is that the tape is transparent. So when the UV light hits it, if any Loctite got underneath the tape, it's going to cure now. And so there's no more solvent properties. And then also another thing with the tape is for the clamshell itself, you have to make sure that the resistance of the clamshell is like less than 50 ohms. And when we tested that, it was around 22.7. And Yeah, so the tape actually ended up working really well, which was nice because we just purchased it for like $7 on Amazon, trying to see if it would work, and it did.
Medtronic make the parts?
So we made the design. We had the CAD design right there, and we asked them for the parts. Some of the stuff, like they have a machine shop down at Medtronic, and so we sent them the design, the CAD design, and we're like, hey, can you make this? He's one of Tommy Cashman on the project. Yeah, it's his dad. He worked on it. Yeah, so he made that for us. Yeah.
Where's this thing?
Was it?
What's supposed to mount here that's not there?
Something else is mounting there.
Oh, so you repurpose?
Yeah. Yeah.
That's only like, what, $100? You guys can spare that?
You know, why spare it?
What's the budget that you had for this?
It was around, I believe, counting materials that they gave us that they already had, $1,000.
So minus that.
Yeah. That they already had. I think it was only around $3,000, $4,000. I think something like that. Maybe the fixture without the stuff that they already gave us. So it's like around 4,000. Yeah.
Machine. Is that used or something?
So we wanted to use theirs, but
Medtronic?
Yeah, we used Medtronic instead. Yeah. We tried going there originally to EC's office, but they were all in use, and so we couldn't use them. We did hear though that his Kia's are a lot better than theirs.
That one looks like an older model.
Yeah, it is. It's the 3200 series, I think, VR 3200. Yeah, another interesting thing about that too is like putting the tubes underneath the kiosks for the surface roughness test. Actually, the tube itself, like since it's clear, it was like seeing right through the tube, and the surface roughness like images were all out of whack. It was actually put in like a Dr. Stegon sputtering machine. Nice. So covered it with like a little bit of copper. Yeah. And then we tried. So that was a pretty cool part of the project. Yeah, of course. Let me know if you have any questions.
Thank you very much. Take it easy. Very cool. Thank you.
Of course. Why, hello. How are all the other projects?
If you're tired, he can.
Yeah, if you're tired, he can punch me in the face. It'll wake you up.
You're beat down. Wow.
So, Flynn. Wasn't here.
You were not here.
That's really.
He was like, "Where's Ari?" We said he's not here, and he said, "That's a little weird." Oh, Clint is our sponsor.
Oh, okay.
Yeah, I'm messing around with him, trying to trick him like our sponsor cared that he was here.
I asked
He did not.
if we want to work for JA or not.
Really?
Yeah.
I'm supposed to give this to you.
Yeah.
That's for you.
See,
The lady was really impressed with our project.
Project management, of course.
on her.
Awesome.
You could get a job. Be a doctor.
Hey, you got
It's
a
an
job here.
internship for the summer.
Yeah. She was like, do you want a job? Do you have anything lined up? I'm like, I have a master's lined up. And she's like, okay. And then she went to Tommy and she's like, do you want a job? And he's like, I already have a job. And she went to take it. And she's like,
She's like, this is for the other two.
yeah. And she's like, all right. She's like, well, I'll give you my. And she's like, and then he can have this card. So we both got a card from Jamila Akrilla. No, this is for me, but I guess it's for Alvin now, actually.
Maybe. My mom is more or less. I've heard things about working for JK.
Yeah.
You're mic'd up, just so you know.
What was it?
Your mic is on. So
Beautiful.
Yeah.
Very shocking things.
It's amazing.
Look at the microphone. I'm like,
The mic. Oh, you're in a picture? picture? Oh, my bad. Oh, do I got a picture with you? Oh, Alex is here.
Say congratulations, you're going to be on to the next thing, and then taking cards, taking money, it'll be like,
Why don't we get a professor or a picture with Professor Stable? We should all do it together.
We should.
Yeah.
Hey, it's good to see you. How's it going, sir?
It's good. How are you?
You doing pretty well? What?
So you want us to explain the entire thing?
Yeah.
This is my first time seeing it. You ready for this? Are you ready for this?
I'm ready for it. Although they're in the way, so.
Did a great job.
He did come by. He just wanted to see how everything was, and then he.
So long, huh? Excuses. Come on, we are at work. So, from square one. So, Medtronic is making us work on these EMG tubes.
Yep.
The way it works is this EMG tube goes down your throat. Yeah. They pump up this ball. It provides an airway while reading the laryngeal and vagus nerves. It's used for open throat surgery. So, what they do is they cut open your throat, whatever nerves they're working on, your scalpel. If it gets too close to one of those nerves, it'll send a signal. Yeah. The silver electrode back to the computer. And
What's the microphone for?
So it'll send an electrode. It'll send a signal up the silver electrode and back to the computer, and the doctor will know not to get too close to that.
Yep.
And so, we were tasked with creating a lab-sized fixture that can test different kinds of Loctite on these EMG tubes. In the Loctite, it covers the silver electrode about 90% of the way in order to ensure that only this part of the electrode reads those nerves and the rest of it isn't interfered with. So pretty much what we did is we built this entire fixture, and the way it works is this EMG tube gets placed on this mandrel by unclipping this clip right here, and then moving this out of the way and sliding the EMG tube on. And then we use a LabVIEW program, and the LabVIEW program allows for this entire fixture to work. And it starts with here, wait, I'll tell you a little bit about the components first before we get into the process. So pretty much here's the mandrel, here's the step motor that spins the mandrel, here's the step motor that moves the screw for the Sure Shot valve. The Sure Shot valve is the valve that allows Loctite air pressure to pass through and disperses the Loctite using this tip, which I will get more into. And then there's the step motor back there, which moves this axis so it can move along the EMG tube. And so the Loctite, the way that it comes out through this Sure Shot valve, it is in a pressurized canister back here. And there's a tube that runs into the pressurized canister and will suck it out, or is pushed out through an outside pressure source compressing that canister. So as you can see, the pressure comes in here, it comes in here, and then the pressurized bottle pushes the Loctite through that tube over to the Sure Shot valve, and then another tube that has pressurized air comes in through here and activates a spring, allowing the Loctite to pass through. And we control the amount of Loctite that passes through this Sure Shot valve based on the pressures that we apply to there. And the pressure is monitored through these gauges. Right.
And one of those is a regulator, right?
So one gauge monitors the pressure of the Loctite canister. The other gauge monitors the pressure that activates the Sure Shot valve.
And this one's adjustable, so you can control the flow?
They're actually both adjustable.
Okay.
Yeah, so they're both adjustable. In fact, whatever we determine the pressure on here to be is what will pass through them and go to these tubes. Perfect. And so pretty much, if you'd like, so once the Loctite is applied, this UV light will turn on and cure the Loctite. And then the mandrel will make a 180-degree rotation, and the process will be repeated and it will be cured. And then
manually rotate it?
No. This is This is rotated through the step motor right there. So I'm going to show you a demonstration right over here.
How is the tube locked?
So you see this right here? So there's a 45-degree cut, and when you ride the tube on, it is aligned right
I
here.
see, yep.
So every time you know that those electrodes are going to be facing in the right direction.
Yep.
So you don't need machine vision in order to determine where those electrodes are.
Yep.
You can
know
just
where
use
it is.
of the motor, exactly. So
is this computer that also runs it?
Yes, this computer does run it, but we're not allowed to run it, unfortunately, here.
No.
Yeah, so right now the process begins. It applies Loctite. And then the silicone tip hides behind the shield in order to prevent curing of the tip.
Got it.
Now it is being cured. And now the mandrel spins 180 degrees, I think you can see right there. And then the process repeats.
And how many uses can you get out of the tip?
So unfortunately, we haven't been able to test that much yet, so we don't know.
Did it cure, just like on this run, for example?
It did. It cured on the first run, and now it's going. Then it twisted 180 degrees, and applied again, and now it's going behind here, and then it cures the other side.
Is the shield successful in preventing?
Yes.
Cure? Okay.
Yes. But of course, we haven't tested it enough in order to be sure over long periods of time. So we didn't have enough time. We ran out. But we did as best we could. So these tips, we actually have multiple different kinds of tips, as you see right here. So we created 3 different tip designs, and we actually made 11 different tips. This red silicone tip turned out to be our best. We had a resin tip, and we had another EcoFlex tip, but the process of making it kind of messed up, and it didn't work out well.
EcoFlex?
Yeah, so we bought it, and then we were talking to you about the EcoFlex. That's right. It was too soft. It didn't end up working, and we didn't have enough time.
That's right. Yeah, I used EcoFlex before, and we
didn't have enough time
very good material
to look for other silicones. Yeah. So we had this amazing mold maker silicone right here, the red, and it worked pretty dang well. Like it did. So like when it applied, we took measurements, and the measurements actually came out to be relatively the same as Medtronic's 0.2 to 0.3 millimeters for that red tip, which works and it's good. And we just need more testing in order to back this up.
How does that stack up in comparison to existing tubes on the surface roughness?
So the way it's distributed, I don't have it up here, but it is a little bit thicker, more towards where it disperses, and then it actually gets thinner as it goes towards the outside. But that thickness at the highest point is only like between 0.2 and 0.3, which is exactly what we're looking for as like a max height. Yeah. So it was good.
And is that an ideal?
It is. Shape? It is. So instead of just covering one electrode, we're covering both of them at the same time, and it's that half moon shape.
So you want it to be thick over the electrode,
but the highest point can't be thicker than the highest point on the current one, because we don't want it to be too thick, because then a 7 millimeter tube turns into an 8 millimeter tube, and we don't want that. But yeah, so far it's been working. But of course, with more testing, we could even optimize and make these tips better. But
how does the computer control airflow? How does the computer control?
It controlled and airbox will control the solenoids. Okay.
Is this open or is it? You got to unscrew it.
Yeah, and we have to unscrew it. There are 2 solenoid here. To turn on the pressure here.
Yep.
And it fits the Loctite to the solenoid. When solenoid turn on, the Loctite will fit. Come up with another solenoid to release. Yeah. Add more. I have to check one more solenoid valves, and when the first solenoid, the first one turn on, second one turn on to release the air out, and it stop.
LabVIEW program?
Yeah.
Awesome.
Lab view program to just control the I/O box.
Oh, okay.
Yeah. And one connect on-way connect to 12 on. The controlled by this one. When it turn on, not will pop so now I need to work at 24 volt DC.
Oh, because the solenoid valves do 24?
24 volt.
Oh, okay.
Yeah. So yeah.
Got it. Heck yeah. Yeah, this is huge.